So welcome back. So in this session, we demonstrate how the method of Regula-Falsi works in solving the nonlinear equation f of x equals to 0. So the first thing we do is to transform the given equation in the form f of x equals to 0. So I simply do that one by taking all the terms on the right-hand side to the left-hand side. So we'll have x cubed plus x squared, now plus 2x minus 10 equals to 0. So that's the equation that we have. And so this implies our f of x will be given by x cubed plus x squared plus 2x minus 10. Since the equation has already specified the interval from where the solution lies, so we'll call this one xl and we call this one xr. So we know the formula is, so the first iteration, let's call it x naught, will be given by xl f of xr minus xr f of xl divided by f of xr minus f of xl. So that's the formula for Regula-Falsi. So let's define everything. So xl is 1.6. f of xl means the value of the function at 1.6. And putting 1.6 into this function, you get negative 0.144. xr is 1.7. Putting f of xr, we get the answer will be 1.203. Indeed, we expect a solution to be between 1.6 and 1.7 because this value is negative, this value is positive. So opposite signs guarantee a solution to be in that interval. So x naught, using these values, x naught, so this is negative, while this one is positive, will be given by 1.6 times 1.203 minus 1.7 times minus 0.144 divided by 1.203 minus 0.144. Now, using your calculator, you find x naught to be 1.610690.423. Remember, when you're doing these approximations, you write all the digits the way the calculator displays for you to get a proper approximation. Now, once you have f of x naught, get f of x naught, which will be given by the value of the function at 1.610690.423. When you work out this, you get negative 5.6432.74055 times 10 raised to negative 3. So we are sure that this is negative. Now, don't forget what we did in the previous method, or the theorem we stated earlier on when we were introducing this chapter, where solution lies for any given equation. So remember, we have said that this is XL and this is XR. So we have used them to get X naught, a value between XL and XR. So we are seeing that the value of the function, from our calculation, the value of the function at XL was negative. The value of the function at XR was positive. And here we have seen that f of X naught is giving us a negative value. So this tells us that a root cannot lie between XL and X naught because the endpoints have both negative, negative. So the root will be within this interval. So therefore, the next value or next iteration, X1, will lie between X naught and XR. So replace XL by X naught. So when we do that one, then the formula becomes X1 equals to X naught f of XR minus XR f of X naught divided by f of XR minus f of X naught. So let's put in the values. So X1 will be X naught from our calculation is 1.610690423 into 1.203 minus 1.7 into negative 5.64327,405 5 times 10 raised to negative 3 over 1.203 minus 5.643274055 times 10 raised to negative 3. Using your calculator, X1 will be given by 1.611107418. Now, if you try to round off this answer to nearest stated accuracy, remember the solution was to express to nearest four significant figures. So this will give us 1.611. And the previous, when you express to nearest four significant figures, 1.611. So because X0 and X1 have the same values, then you say, therefore, the solution is X equals to 1.611. Is to nearest four significant figures. So you see that the rate of convergence of this method as compared to the first method of bisection, this one is much easier than the previous one. So we have only done 2 steps, and for this particular problem, we have the answer. So if you do the same steps, you're getting iteration X2, try to work it out and see that the answer will be 1.611123635, which also when you round off to four significant figures, you still get 1.6111. So you don't have, for this particular method, X2 is unnecessary because already X0 and X1 rounded off to the stated level of accuracy, you have the same answers. But you can just do that one for confirmation, but stopping at X1 will make your answer to be valid because X0 and X1 both rounded off to four significant figures have the same answer of 1.611. Thank you.